Hello, my name is Sergey Lukyanchikov. I assist our customers and partners with transition to production use of artificial intelligence and machine learning. Although many of us have already a sound understanding of what AI/ML is about, certain specifics of its production use may deserve a conversation. Nowadays, production-level AI/ML is real-time and is both in-platform and distributed. In this session, we'll take a closer look at each of these properties and explain the best practices that InterSystems IRIS data platform provides to support them. Talking about real-time, we need to mention some concrete challenges that each company that implements real-time AI/ML solution faces. First, the efficiency of development and deployment of AI/ML mechanisms that was okay for the so-called offline era is no longer acceptable in real time. We need a zero-barrier approach that embraces a wide spectrum of development instruments, user personas, and artifacts, allowing to continuously develop and deploy AI/ML mechanisms into AI/ML solutions running in production mode. Second, for AI/ML solutions to support real-time decision-making, the previous day mono toolset approach, for example, do in Python anything you can, is no longer sustainable because of the complexity coming with the real-time analytical processes that we implement. We are forced to continuously integrate, or rather reintegrate, which is more frequently the case, all the various moving parts on the go, while our production solutions keep doing their AI/ML work. Third, our AI/ML solutions need to become autonomous and self-adapting to cope with data volume, velocity, and variety, the three most widely known factors of real-time. And let's add another one, the absence of the last record in our real-time dataset. These are the results of a survey that was conducted on an audience of some 800 IT professionals that specialize on real-time and streaming data. According to the respondents, in 2019, artificial intelligence and machine learning applications were the fourth most active consumers of real-time data. When asked about their projections for 2020, the same respondents attributed the top position in the chart to AI/ML scenarios, while emphasizing the importance of DevOps paradigms for the implementation of real-time AI/ML. The results of that survey are reassuring for us, and we are going to continue talking about the in-platform aspect of production-level AI/ML. The DevOps paradigm requires any solution that claims to be a platform to support in a holistic end-to-end way several macro mechanisms. In the case of AI/ML platforms, given the previously introduced real-time aspect, and given the guidance already available from thought leaders, we conclude that a real-time AI/ML platform is expected to provide the following macro mechanisms. Continuous deployment, or CD, the real-time in-platform equivalent of classical one-off development of AI/ML mechanisms. Under continuous deployment, the essence stays the same. We go through the same steps while creating or adjusting our code. What changes is the frequency of improvements and the degree of embeddedness of our AI/ML mechanisms in the analytical pipelines implemented in the platform. Continuous integration, or CI, is the equivalent of software product assembly. The distinction of continuous integration in an AI/ML setup is the permanent necessity to change what could be called the functional design of an AI/ML solution, sometimes slightly, sometimes rather drastically, while guaranteeing continuity of the production level version of it currently running. Continuous training, or CT, the equivalent of continuous testing in canonical DevOps in our AI/ML setup, presumes that validation of an AI/ML solution model is something that is functioning A, in real time, and B, without involving data scientists, no developers, even if the nature of the data or the phenomenon represented through that data may change over time. InterSystems IRIS is the data platform with a rich spectrum of highly integrated functionality. Architecturally, it has an input layer, a comprehensive data acquisition and integration toolbox, several core layers, a set of engines to manage and operate data structures, business processes, and users, and the output layer, a portfolio of permanently evolving in-platform applied toolboxes such as business intelligence, artificial intelligence and machine learning, natural language processing, and so on. Unlike in neural networks, in InterSystems IRIS, the core layers are not hidden. On the contrary, its core functionality is fully transparent and is meant for easy integration with any external system or application. This very strong advantage of InterSystems IRIS results in its capacity to interoperate with a mix of open source and proprietary software that delivers, together with IRIS, the DevOps paradigm in our real-time AI/ML in-platform setup. Indeed, interoperability with development environments such as Jupyter, Visual Studio, Eclipse, turns the input layer of IRIS into a continuous deployment layer. Interoperability with freestyle mathematical modeling environments such as Python, R, or Julia turns core layers of IRIS into continuous integration layers. Finally, interoperability with innovative frameworks such as H2O, DataRobot, Alteryx, and the list is growing, turns the output layer of IRIS into the continuous training layer. So how exactly this whole in-platform real-time DevOps compliant construct is functioning? There are three DevOps macro mechanisms, CD, CI, and CT, that we already mentioned, that give us a top-level perspective. Let us consider CD, continuous deployment. Here, we address code development or modification of the existing code that most of the times is already deployed in the platform or even put into production through a concrete AI/ML application developed and running in the platform. In any case, we need our data scientists first implement their AI/ML mechanisms in external development tools like Jupyter that helps writing, debugging, testing code in modeling languages like Python. This will be the design phase with all the freedom it presumes. But once the AI/ML mechanisms are built, they need to be transferred into the platform as seamlessly as possible. This is where interoperability power of InterSystems IRIS kicks in. Anything developed in Jupyter can be replicated as a business process in IRIS. Any business process in IRIS can be replicated to Jupyter, and its AI/ML relevant portions will be modified, debugged, tested in Jupyter. We place this emphasis on Jupyter because it is the de facto code editor with data scientists. But many of them would prefer using IDEs, the integrated development environments, that combine AI/ML code editing with generalist coding in various languages, including, of course, ObjectScript, the native development language of InterSystems IRIS. Continuous deployment is followed by continuous integration, CI. Under classical DevOps, this macro mechanism is responsible for the assembly of code into solutions. In our real-time AI/ML setup, many solutions will share the same features. For example, data buffering queues for model application, training, and accuracy check, or data structures for modeling output distribution, forecasts, clusters, classifications, and so on. AI/ML pipelines that implement sequencing and decision-making for a pool of AI/ML mechanisms that are involved in an AI/ML solution, and as well as interoperability with the mathematical modeling environments. InterSystems IRIS provides a rich spectrum of instruments and accelerators for an efficient, visual, low-code, and at the same time fully employable in an expert developer mode continuous integration. We will have a separate occasion in this session to walk you through the examples of the main AI/ML in-platform instrument of InterSystems IRIS. But we must also mention upfront the important role of the solution templates that we provide that accelerate significantly time to solution for those of our customers and partners that are using InterSystems IRIS as their real-time AI/ML platform. Continuous training or self-training, our CT macro mechanism, builds on the previous two, CD and CI, but has its own distinctive identity. In plain words, continuous training is something that functions most of the times outside the platform in various mathematical modeling environments, freestyle ones like Python or Julia, or specialized one like H2O or DataRobot. Its main objective is to convert existing models, including the existing choice of input variables for the models, to newly trained models and a different set of input variables when the existing accuracy is no longer satisfactory. It is key to mention that continuous training is continuous because the in-platform functionality behind it is designed for continuous running of analytical pipelines, embracing all thinkable underlying AML functionality coming from the mathematical modeling environments it interoperates with. Only continuous training can handle real-time. Only in-platform continuous training can handle real-time efficiently. InterSystems IRIS takes you literally to the edge of continuous training efficiency due to its AIML platform functionality, the examples of which we will see next. So in this screen, what we see in the left part of the screen is an example taken from a real-life prototype that presents a sequence of steps that are needed in order to train a stack of models. So, for example, in this particular case, we have the full sequence that we see in this slide implemented using Python language, but some portions are implemented in R. So that gives us an idea of how easily different modeling languages can be combined using InterSystems IRIS visual application composition paradigm. Some portions can even be edited in the third language here, in this case, in Julia. The execution is fully trackable using the visual logging tools, and you can see in the middle part of that slide the examples of how each elementary step in the process can be traced and how it can be audited to the details of what concrete portion of script has been transferred to this or that mathematical modeling environment. Finally, using graphical tools either embedded in the platform, like you see in the upper part, or coming from the mathematical modeling environment, like those two nice R-based graphs, we can control and feel and have a sense of how well our AIML solution is functioning. And for ease, we have added in little circles the markers of belonging to this or that macro mechanism we've discussed before. Apart from the pure interoperability with the mathematical modeling environments, we need to mention the ability of InterSystems IRIS to allow a complete visual development of our applications, and that's the example that we are presenting in that slide. You can see that the portion that we've seen on the left side of the slide is merely a step in another more high-level process that you see in the middle part, and that presents two modes, actually the training mode and the scoring or model application mode that are implemented in that solution. And there is one more, even more higher level that is available in that solution that actually compresses all that functionality in ever-running loop called analyzer loop. So that gives us a possibility to visually design and implement and keep self-documenting whatever solution we need to implement. When we said that any AIML portion of our process can be editable in Jupyter, so we meant this, and actually the example that I'm showing right now shows us how easily we can edit a particular process that is deployed in the platform, but if we're interested in changing just the specific parts of it, we can do it using the Jupyter code editor that allows us to, so to speak, to extract certain portions, experiment with them, test them, check them visually, and then redeploy back in the process. For those developers, and there are surely going to be some of the developers that would need a full access to the content of the business process, including all the markup language that implements the visual elements, including the machine learning content in Python or any other language that is used while creating that process. Like we said before, we are providing access via at least 3 IDEs. The first of those IDEs is our own IRIS Studio in the upper part of the slide. Then in the central part, mid part, you see an example of editing the same process using Visual Studio Code with a plugin for InterSystems IRIS. And in the lower part, we give an example of editing the same old process using the Eclipse IDE. So basically, if that means that if the people on your team prefer using different environments, different IDEs, they're free to choose their IDEs. They will still be working with the same set of platform processes, and each of them will be able to contribute his part without the need to change his preferred environment. An important layer that is coming together with the platform, and we should make a special emphasis on it, is the set of pre-configured integration components available in the graphical process composer available in the platform. So using those pre-configured components, we are adding an element of decision-making logic to our otherwise flat and monolithic analytical script, or a collection of scripts that link our AI/ML content with the surrounding reality that could manifest itself through different messages coming from the surrounding systems, sometimes systems like SCADA or MES, ERP systems, CRM systems, and so on. So this layer and this graphical paradigm, apart from being visual and apart from accelerating our development process, it can serve a very interesting role of actually making our AI/ML content live and reactive to what is going on around in the landscape that we have. We are structuring our solutions in InterSystems IRIS, and we have that privilege not as a single monolithic process, but we can choose how many processes we implement in order to implement the solution we have. So in this example, for example, we have 4 processes, each of them playing its own role and playing its part in the functioning of the overall solution. So one of them is doing the AI/ML work. It's called Analyzer. There's another one called Monitor that is responsible for measuring the accuracy of functioning of the AI/ML portion. There is a special process that controls the dynamics of the data arriving real time and placed on the processing buffers for model application, for model training, for model accuracy check. And there is a 4th process that is responsible for communicating with the piece of equipment that we're taking the data from. So this is just a very compact example of what otherwise could be called an agent-based system, and that is most of the times would represent the most viable approach to cope with the velocity, variety, and the volume of the data we have. Now we would like to give a very brief set of examples of the main application areas for in-platform AI/ML. And we would like to start from AI/ML robotization, that is developing the agent system idea that we've presented in the previous slide, and visualizes a prototype that is basically based on those 4 processes that we've presented in the previous slide. So we see that we can automate our AI/ML content not only as a single process that has the start and the end, but as a sort of family of processes that changes its behavior depending on the situation it faces. Those processes that communicate with each other, they have certain rules of interaction among each others, and that adds additional robustness to the whole system and additional performance dimension to the solution that we implement using that paradigm. Continuing the topic of AI/ML robotization, we have to mention autonomy and self-learning. So in this slide, we are presenting an example of a prototype that, after a finite numbers of retraining, is continuing to function in a completely autonomous way. So you can see it in the lower part of the slide that after a number of red stripes, that each of which is standing for a retrain session. Further working is not interrupted, so the prototype has learned enough from the data sets it has been exposed to continue working at an acceptable level of accuracy of detection of the target events it's working with. This prototype is referring to the area of sentiment analysis. And in the upper part of that slide, you see the dynamics of the quality of the models training that are embedded in the prototype. So you see that gradually, as the quality of the detection work performed by the model is increasing, the prototype stops needing any further training and continues functioning autonomously. So that's what we refer to as self-learning. Another example comes from yet one more prototype, and I'm pretty sure you are already acquainted with the topic of integrated ML. So in this case, we are showing that integrated ML can be used not only in an interactive mode using your SQL client, but can also be embedded in a productive pipeline like this one. And in this pipeline, we are implementing several models that form a competitive model mix. So we can see that in certain situations, the detection quality delivered through the AutoML, in this case H2O framework, is superior to the so-called handmade models that are usually used in most of the solutions. So that means that our integrated ML can also provide a significant help out in the tasks that are based on automation and autonomous functioning of AI/ML solutions. Especially when we need to rapidly detect the relative importance of our input variables with which we are working in this or that solution. AutoML, implemented in the integrated ML framework of InterSystems IRIS, could be really instrumental. We mentioned in the very beginning of this presentation the distributed ML dimension, and next several slides are very briefly presenting our capacities in this domain. Distributed ML is the phenomenon that gains more and more terrain in practical AI/ML implementations, and refers to the situations when not all the computational work or not all the data is supposed to be either processed or be present at a single local system. In this case, InterSystems IRIS. So there could be situations when it could be beneficial delegating some high-load processing, either model training or data preparation, to an external provider. That could be, I'll give some examples, Amazon Web Services or Microsoft Azure or Google Cloud Platform. So in this slide I'm showing right now, we present an example of a task that's a modeling task that the model is being trained, delegated to AWS, and we are ready to pay for 36 billable seconds for the work that we would like to take beyond the limits of our local IRIS instance in order not to overload the productive processes that are being deployed there. This other example in this slide shows a similar situation when we need to involve Microsoft Azure. And you see how basically how compatible this action it can be performed in absolutely similar manner. We don't need to change the way we are working with our visual processes. We just add certain steps in the process that allow us to delegate certain machine learning work or data processing work to an external provider, in this case Microsoft Azure, but stay in full control of what's going on in here, and getting back the results in order to continue executing our process, our analytical pipeline in InterSystems IRIS. Another example shows us exactly a concrete situation. For example, if we need to have a quick comparison of how well our model is trained in our IRIS system. What we can do, we can ask Microsoft Azure, repeat similar steps using their tools, and return us the results of such a training, just to, like in this particular example, for us to see that what the analytical work that is doing by IRIS is at a good level, and we can continue using that process. We're not deteriorating the quality of our models compared to the outside providers. One more example that is related rather not to computations, but to using a different type of infrastructure, in this case quantum computers, that is becoming more and more important in certain domains, especially related with finance, related with security. So in this little prototype, we are demonstrating the capacity of InterSystems IRIS to interact with quantum machines that are also a sort of distributed resource that we will probably not have in our full possession, but which we can use on a commercial basis. And we can use it in the same manner. We are actually using the local tools like Python, R, and Julia that are deployed locally. Finally, just to avoid the impression that InterSystems IRIS is handling only highly complicated cases or cases that are linked to some interchanges with technologies that will impose some barrier of entry in the beginning. We are presenting in that slide the example of how easily a PMML specification of a model that has been trained somewhere outside the reach of our control can be ingested in InterSystems IRIS and can be executed and applied to real-time data without the need to actually do the whole model training work in InterSystems IRIS or under its control. So this slide confirms that we are not exposing our customers and partners to the so-called platform slavery. We are completely open-ended construction that is available for all thinkable interoperability scenarios with mathematical environments. It is important to mention that, of course, despite our ML and AI focus in this session, InterSystems IRIS is, in its DNA, it's a data platform, and as such, it has a number of distinctive strengths that we would like to briefly mention here. So, first of all, let's mention multimodal database management that allows us to apply what we could call high-level data models like relational data model or object data model only where appropriate. So the data that, especially the data coming from SCADA systems, MES systems, that may be easier to process without representing them as a relational table, can be done so and done so efficiently. InterSystems IRIS, and we could see it from some of the previous slides, has BI capabilities, so we are able to use our own BI tools to immediately deliver a visual representation of all the analytics, of all the information that is circulating through our AI/ML solution. InterSystems IRIS has a powerful integration framework that allows us to connect to a virtually unlimited variety of data sources and data destinations. Our API management component is capable of delivering the results of AI/ML computation to the various systems by reusing and using efficiently their API. Our development environment is there for rapid application development, embedding of AI/ML mechanisms. InterSystems IRIS is a high reliability environment due to high availability and disaster recovery and configuration options. And finally, InterSystems IRIS is supporting flexible deployment in virtualized environments, on physical servers, in private and public clouds, and inside Docker containers. Based on what we have seen and discussed so far, so I hope you agree that InterSystems IRIS has reasons to be called an all-purpose real-time AI/ML platform. The all-purpose nature of our platform is proven in action through the de facto absence of restrictions on the complexity of implemented computations. The ability of InterSystems IRIS to combine in real time execution of scenarios from various industries, the exceptional adaptability of any in-platform functions and mechanisms to concrete needs of the users. Some of the examples of typical industry scenarios, depending on the real-time AI/ML that we assisted our customers and partners implementing in InterSystems IRIS are, and let me do a quick zoom here, our estimation of equipment failure probability based on real-time sensor data, optimization of the audience of a recommendation system as a part of our customer portal, monitoring of dependencies among the flows of patients in a national healthcare system. We will readily provide support with formulation of real-time AI/ML scenarios relevant to your company specifics, run collaborative prototyping based on InterSystems IRIS platform, design and execute a roadmap for implementation of artificial intelligence and machine learning in your manufacturing and management processes. For a more specific dialogue with those of our audience that found this session interesting, we would recommend taking a live contact with us. The contact email of our AI/ML expert team is mltoolkit@intersystems.com. Drop us a line and we'll organize a web call to start this journey. Thank you very much for your time and interest to our session. We look forward to hearing from you. Goodbye.